next presentation about Morphia, JPA for MongoDB. So it's about painkillers for developers. Let's hear. Mr. Krenn, please.
Hi, I'm Philipp. I'm from beautiful Vienna. Sorry? No, not yet. Can you all hear me? Great. I'm from Vienna, where I work at a company and doing the cloud and NoSQL stuff there, and I run a big Viennese meetup group, ViennaDB, where we talk about various databases, and MongoDB is one of them. So, who uses JPA? Anyone? Okay, a few. Who uses MongoDB? Okay, very few. Does anyone use Morphia? No. Good. So I can tell you all about it. Morphia is like JPA for MongoDB, but it's better. Why is it better? If you're using JPA, you might have seen something like that. I hope you can read that. Oh, wait. I'll switch the color theme. We'll just put it to black and white. I hope that's better. So that's possibly, if you have a complicated join, that's what a join might look like in JPA. And I know if you've used it long enough, you say, okay, maybe it's okay, but maybe it's not so okay. The problem is relations versus objects. So the relational model, relational databases use doesn't really fit that well object-oriented languages like Java. So that where MongoDB comes in, because it's not relational, it just uses JSON documents instead of rows. And yeah, the tables are called collections, but that's basically the same. It's just there is no schema. And instead of rows, you just have single JSON documents. So that's what a row or a document would look like. You have, for example, attributes like names, age, stuff like that. You can stuff sub-documents into it. Like here we have an address which consists of a city and postal code. And you can also stuff arrays, those parentheses, which might be objects again, into a single document. So you have all these structures which map relatively directly to Java code. Now, how do you access it from Java? You can use the official Java driver, but that would look something like that. So you have a basic DB object, and you stuff in all your attributes into that. And if you have a sub-document, you would need to create a new basic DB object and stuff all the attributes into that. And then if you have an array, you would need to create a list, for example, and stuff all the attributes into that. So that's not really that nice to develop. And when we saw that, we said, that's not really what we want to use. So what can you use instead? Morphia is the JPA mapper built on top of that. It's not an object-relational mapper because there are no relations in MongoDB, but it's an object-document mapper because there are only documents. So it's just POJO, plain old Java objects, plus annotations. It's generally relatively lightweight, and it's type-safe and type-preserving. So you don't have to mess around with your types or do any casts on your own. That's what the library does for you. What do you need? There is the base Mongo Java driver, which is basically like JDBC in a relational world. And on top of that, you have Morphia, which is basically like JPA. So if you want to see some code, there are code samples. All the code I'll show are available there. To run it, all you need is Java and Gradle. So you can just run Gradle test, and it will run the test for you. You can either use a standard on MongoDB database, or if you don't have a database, a MongoDB database, it will just load the dependency and run it in the background. So just Java and Gradle, and you can get up and running. So when we think about JPA, we're mostly thinking about annotations. How do they look like? If I want to add a collection or table in the relational world, we would have our class, which is a company in that example, and we say we want the entity to have the name or the collection name company in the database, and we don't want to store the actual class name because we don't need it in that example in the database. And then we say it has an ID, which we define as an object ID, and annotate with ID. And we need a no-arg default constructor to create the object, and that's the easiest way to create an entity in the database. Does anyone have an idea why we don't use a nice integer or long ID? Because this won't really look nice. It's, I don't know, like 20 bytes random hexadecimal. The problem is MongoDB, as we'll see in my second talk about replication, is very good at using multiple nodes. So there's no central node to generate one ID, which will auto-increment, which would be quite a bottleneck if you would need one instance which creates all your IDs. That won't work so well. That's why those object IDs will be generated mainly by the driver, or the database can generate it itself. And the objects, your documents, will have those first a bit weird IDs. Generally, do not use dashes in the collection name. The problem is the shell to access the database, so the interface to interact with it, is JavaScript based. Does anyone have an idea what happens if you use a dash in a collection name then? Since it's JavaScript, a dash is a subtraction, so it will try to subtract the second string from the first one, and it will fail miserably. There are ways around it, but you should avoid it because it's painful and more typing after that. What you should not do is copy the value attribute of the collection name, because since there is no schema, you can stuff just any data into a collection. And then you can stuff various objects into one collection, and you can't really decide which is which, and which might create a lot of chaos. So if you're starting out with the code and you start copying around it, make sure you're using unique collection names. And do not use strings for the ID. You can do that, but terrible things will happen. If you search Stack Overflow, many people had problems with that. So one thing, at first I said the relational model does not fit JPA so well, or the relational model does not fit Java so well. One place where we can also see that is polymorphism. So assuming we have a base class, which is an employee, and we have two subclasses, a manager with an attribute and a worker entity with another attribute, in the relational world you have three ways to model the data. You can either use a union table where you put all your subclasses in. So you would just have an employee table, but that would contain null values because it doesn't have all the attributes. The second option is just to create the concrete instances. So you would have a worker and a manager table. But then if you want to get all employees, you would need two queries. And the more subclasses you have, the more queries you would need. So that's not so nice. Or you could just create the base class. So you have a table called employee. And then you have two subclasses, worker and manager, with their specific attributes. And you would always need to join those together to get the full document, which is also not so nice. So in Morphia, you would just annotate the abstract base class, probably at the object ID. In this case, we are storing the class name, so we can later know do we have a manager or do we have a worker entity. And the JSON document we would get will look like that. So we have the ID, the class name, where we can say afterwards, okay, I only want managers or I only want workers. And then you have the name, both of those have it. And one just have the approved funds and the other the year's experience. And since there's no schema and JSON doesn't dictate the specific structure, you will just have the right document for each entity. Properties. There are some things you can do with properties. So at first, you can just add properties, and they will end in your database. Nothing specific to do there. You can say also load will load an attribute if you have renamed it. Since there's no schema, you cannot really change the schema. So this is a way around it to say, okay, we've renamed the field. So it has been named last name. Now it's called surname. So if there's no surname, check, is there a last name? And if it's available, just load that into that field. And that will just happen behind the scene, and there's nothing for you to do. Then you have two attributes. A Boolean object data type and a Boolean primitive data type. We'll just come to that difference. And you can also say, while the name in Java is pretty long, I just want to keep it short in the database. So the JSON attribute name would be higher. And just practice. I'm always using chainable setters, which is just nicer once you get used to them. So in general, do shorten property names. The thing is, since there is no schema, you will always store the full JSON document. So if you have very long keys for the attributes, you will always need to store them in every document, which is maybe okay on disk, but it's very expensive for RAM. So, and if you're using just a Boolean, which is just a byte, and your name is something like 20 characters long, you will need to use a lot of space, or you're wasting a lot of space. Do use object data types. The problem is, with primitive data types, there are no null values. So even if the value is not set, the database will add it. So the default value. So if you're using a primitive integer, it will always have the value null, 0. But if you're using the object data type and you don't set it, it just doesn't appear in the JSON document because it's null. And then when you load it, the mapper will automatically see, okay, there's nothing there, it must be null, everything good. And provide chainable setters. Indexes work more or less the same like in relational databases, so nothing interesting there. So you can either annotate an attribute, so you can index it, or you can also say it's unique. And you can combine indexes, so you can index surname and first name in one thing. Looks like that. One thing, in relational databases, you have transactions, where you have pessimistic logging. So in relational databases, you always assume the worst case. You say, okay, something bad might happen. That's my block. Nobody else is allowed to touch that while I'm editing it. In MongoDB, you're just taking the opposite approach, where you use optimistic logging. You can annotate your entities with that thing, just a version, and which has a long value. And every document will then have a version. So the first time you save it, it will have version 1. The second time you save it, 2, etc. And when you issue an update operation, it will check, does it have the previous number or just the same number I had, and am I just incrementing it by 1? If you're incrementing it by more, someone else has written it, and you will get an exception. So there's no locking. Everybody is actually allowed to start editing, but once it sees, okay, there is a problem, the database will still alert you. So it's not easy to override someone else's rights. So that's kind of good protection. And in generally, there are no joins. You have two options to include sub-objects. You can either embed them, so you will stuff the whole object into the other document, or you can reference it, and those are auto-loaded. So they are not in the same document, but they are referenced, and when you access it via Morphia, it will auto-load the other thing, so it's issue a second query, and you can simply access it then. So that's very convenient. Queries are pretty much the same you might see somewhere else. So you just have, for example, a data store, and then you save your objects, and then you can get back the object ID. You can work further with that. Getting data is also very simple. For example, here I'm just saying from my employee entity, I'm using the abstract base class here, so I would get both managers and workers here. there I say the field email equals my field email get, and it just gets single object. Or if you expect an array, if you get multiple results, you can just say, give me a list, and then you call as list, and it will just return you a statically typed list. Watch out. Very common problem. Equals is the Java thing. Equal is the Morphia thing. Don't mix those up. Finding that in your code is really hard. Performance tips. Try to normalize your fields. For example, the email address, always just store the lowercase thing, so you can do exact matches. Otherwise, there are many other queries we won't go over now. You could use regular expressions, but those are really slow. So if you say, okay, my email address, ignore case, just regular expression, you can do that, but it's really slow. Try to avoid that. And there are many more powerful queries like exists, does not exist, greater, you have the sort, skip, limit, all the features you would expect from a relational database. And MongoDB offers loads of other features like cat collections and other stuff. We don't have time. I will shortly show you 3 patterns. So what we are always doing is we're providing a base class which just says, okay, that's my abstract base class, creation date, last change date, and the version, and every other class we're using just inherits from that. You have the no-arg constructor and a few getters. And we're always populating in a pre-persist hook, more or less, when was it created and when was the entity last changed. And that's basically it. The nice thing is, once you've done that, you can use abstracts in your query. So before, we had to use one save for companies, one for employees, etc. Now we can just use whatever inherits from our base class, save that. And you can use generics like you would be used in Java, which is pretty nice. There are converters. For example, not all data types are supported by Morphia, like big decimals. So you can either serialize them into the database, but that's then the serialized blob. Not so nice. You can do the trick with the pre-persistent post-load thing, so you just pass it out to a string and then before writing, and then you just pass it back from a string when you load it. Also not so nice because you need to do that for every attribute, or you can write your own converter, which is the code on the top, and the thing you need then is just you said, okay, this class uses a converter, and then you can just use the data type just like regular. So if you have your own complex data types, or you're using some other not so common data types, you can just write your own converters, and Morphia will handle that gracefully for you. And something, since the IDs are not numeric and auto-incrementing, you can build that on your own. So you can just provide one entity which contains all your counters, basically, and using that, you can call that function, and then in the end, you just say, okay, do I have already something counting that? And then I'm incrementing it, and I can provide counters for whatever I need. So in this example here, we're having an employee, and we want to count the employees per company. So each company starts at employee 1,000, and the second employee for each company is 1,001, etc. So you can easily provide counters with Morphia. That's just a pattern we found very useful because we needed that many times. Future. Yeah. Java is the reference implementation, so it's not going anywhere. There's soon driver version 3, so we will get the major update. Morpheus future, at the moment it's sleeping, and I have the hope that after the Java driver has been updated, the development will increase again. But right now it's a bit sleepy, and we're still at version 108. There are 2 more before 1.0, and hopefully we'll get there soon. Any questions?
I will ask the first question. What about lazy loading?
You mean when referencing others? Yes, you can annotate it with load lazily. And
default is eager.
The default fetching is eager, which is nice if you're starting out because it's very quick and you don't have to think about anything. But you can also annotate it to get the query afterwards.
Thank you. Other questions?
Have you tried exploring Spring data as an alternative to Morphia?
We started out with Morphia something like 2.5 or 3 years ago, so Spring data was not there yet. And I mean, I'm kind of monitoring it, but it's not so popular, at least from MongoDB, or from at least the feeling I get. Also, the questions on Stack Overflow, there are some Morphia questions, but there are very few Spring data questions, so I'm a bit skeptical if many people are using it actually. And I always get the feeling that the Spring data thing is it tries to cover everything, so it just needs to use like the most common denominator, and you're probably losing some features because you're kind of wrapping all those NoSQL and SQL databases and just need to provide an interface for that. So I'm not sure if that's really getting to the full power of all the databases.
Okay, thanks.
More questions?
Okay, I'm not using Morphia or MongoDB actually, but I have seen it a few weeks ago, and I was wondering, since there are no transactions in the sense like in relational databases, it's only a transactional unit is when you save the whole document. Document is all or nothing. Now I'm wondering, can you tell me what is your best practice when you want to save, let's say, 3 documents, 3 different documents, each in different collection, and you want to do it in 1 unit of work to happen? Do you have some pattern or something, some good advice when you do that?
Okay, right. So there is no multi-document transaction. That's right. So it's just a single document.
Okay.
I think there are 2 good ways to approach it and 1 bad way. So the good way is the MongoDB approach is since there's only a single document transaction, you need to embed it. So you just cannot have different documents. That's the common approach. If it needs to go together, it's just embedding and not referencing. If that's not possible, MongoDB is possibly not the best choice for you. It's just the hard answer. And the not so good solution is there are some homegrown transaction managers which have their own table where they just prepare a transaction and then they try to write it to all the documents and then they have a cleanup function if it goes wrong. But I don't think that's... Yeah, it's like a manual 2-phase commit, and there are some projects on GitHub, but they're not that well maintained, and I'm very skeptical if they will work in every situation. And I'm not sure if there is not some edge case where they might mess up your data. So if you really need multi-document transactions, like you're wiring money from A to B, and you need to keep track of those two, MongoDB is possibly just not the best solution. Just the hard answer.
Just one question. Is there any limit on the size of the documents that are stored? And if the document gets too big, what are the best practices? Is there some sort of sharding or splitting the content on the other nodes or that sort of stuff?
Right. So one document is limited to 16 megabytes of data. And if you exceed that, there is GridFS, which is actually just a wrapper around it, which chunks data into 256K pieces, and there's probably a terabyte limit also somewhere there per file. So the regular JSON document is limited to 16 megabytes, which should be sufficient for most regular data. But if you want to store binaries or anything else, there is GridFS, which will chunk your data and store it in MongoDB. Thanks.
Any other questions?
Okay, thanks.
If not, sorry.
Just one question about who's maintaining Morphia.
Morphia is so.
Is there any company behind?
Yeah, so the company behind MongoDB is MongoDB Inc., and they are now maintaining Morphia. It's had kind of a difficult path because it was started as a community effort. Then MongoDB hired the main contributor. Then the project more or less died because he didn't have time for it. And then they endorsed it officially because it was widely used. So they took it over. It got a year or so of good attention, and now for a few months it's sleeping again, and I hope it's picking up after the release of the base Java driver in version 3. So, but in general, the company behind the database itself is both supporting the Java driver and Morphia. Thank you.
Thank you very much.